Imagine an industrial refinery protected by a multi-million-dollar electronic warfare dome. High-power RF jammers are blasting thousands of watts of electromagnetic noise across the 2.4, 5.8, and 900 MHz bands. Advanced spectrum analyzers scan the airspace 24/7. To any corporate security auditor, this facility looks completely impenetrable. Suddenly, an FPV quadcopter approaches from the tree line, traveling at 100 kilometers per hour. The jammers are running at maximum capacity, yet the drone's flight path remains rock solid. The high-definition video feed remains crystal clear, and the control link experiences zero packet loss. The multi-million-dollar RF defense system is not malfunctioning. It is simply fighting a ghost. The drone is emitting absolutely zero radio frequency energy. Welcome back to BlackBox UAV. Today, we are analyzing the ultimate architectural vulnerability in modern perimeter defense: zero RF fiber-optic drones. We will break down the physics of glass-wire telemetry, explain why traditional electronic warfare is completely obsolete against physical light links, and explore the physical detection systems required to survive this new era. To understand why electronic countermeasures fail, we must look at the physical transmission medium. Traditional drones rely on electromagnetic radiation, radio waves propagating through the air between the transmitter and the receiver. A fiber-optic drone completely eliminates the air from the equation. Mounted to the frame of the drone is a specialized microspool holding up to 20 kilometers of ultra-thin, high-strength optical fiber. As the drone flies, the glass fiber unspools from the rear with near-zero mechanical tension. Telemetry and uncompressed high-definition video are converted into light pulses by an onboard optical transceiver. These light signals travel through the glass thread directly to the ground control station. Because light propagates inside the optical core via total internal reflection, zero electromagnetic energy leaks into the surrounding atmosphere. The RF spectrum analyzer sees absolutely 0 Hz of transmission. There is no carrier frequency, no digital modulation, and no telemetry headers to intercept. The drone is acoustically and physically present, but completely invisible in the radio spectrum. This physical architecture systematically dismantles every single layer of modern radio frequency security. First, passive RF scanners are rendered 100% blind. They are programmed to detect wireless digital signatures. Against a physical glass link, they register only ambient background noise. Second, RF jammers are rendered useless. Throwing megawatts of electromagnetic noise into the air does nothing to a light pulse moving inside a glass cable. You cannot jam a beam of light inside a wire with a radio wave. Third, GNSS spoofing and jamming are entirely irrelevant. Fiber-optic drones do not require GPS signals to navigate. They are guided directly by human pilots receiving zero-latency HD video, or by optical flow and onboard inertial sensors. Finally, protocol manipulation and cyber takeover attacks are physically impossible. You cannot execute a packet injection attack or hijack a command link if you do not have physical access to the glass wire. The entire digital kill chain collapses instantaneously. However, true engineering requires critical analysis. Fiber-optic flight is not without physical vulnerabilities. The microspool adds dead weight, creating a payload penalty that reduces flight time and maneuverability. The thin glass strand is vulnerable to mechanical snagging if flown aggressively through dense foliage, high-voltage power lines, or sharp industrial structures. A severed cable immediately terminates the control link, requiring automated fail-safe routines. So, how do you defend a critical facility against a threat that produces zero radio footprint? You must abandon electronic warfare and return to physical detection and hard-kill integration. Because a drone cannot hide the laws of aerodynamics, Micro-Doppler radars will still detect the physical Doppler signature of its rotating propellers. Networked acoustic arrays can capture the mechanical sound frequencies produced by the motors. AI-powered thermal cameras can lock onto the heat signature of the battery and electric motors. Once detected, neutralization requires physical force, kinetic interceptor drones, automated netting systems, or directed energy lasers. The rise of zero RF fiber-optic drones marks the end of the electronic warfare monopoly in perimeter defense. Facilities that rely solely on radio frequency jamming are protecting themselves against yesterday's threats. True security in 2026 demands a multi-layered, physical-first architecture that tracks the physical presence of the threat, not just its digital footprint. If this engineering breakdown expanded your understanding of modern defense architecture, hit the like button so this data reaches the security community. Subscribe to BlackBox UAV for uncompromised aerospace analysis. For direct engineering consultation on custom C-UAS site assessments, operational geometries, or tailored defensive architectures, reach out through my secure contact link in the pinned comment below. We deliver uncompromising engineering truth. Stay secure, and I will see you in the next analysis.